I'm going to go through the next thing on this, so we'll be getting close to finishing those anyway, if you haven't already. So I'm just going to go through the solving of cubic equations, and it's not that it's really just applying the factorising of cubics to solving the equations, just like we would when we're solving quadratics. We factorise first, use the null factor law, and that way we can find our solutions. So the first example we've got there is, okay, it's already factorised. So we've got our three factors, x minus 2 times x plus 1 times x plus 3. And so if by multiplying them together you get an answer of 0, it must mean, just like with a quadratic that's factorised, it means that x minus 2 is equal to 0, which would mean x is equal to 2, or in this case x could also be equal to -1, or x is equal to -3. Okay, so we just want to apply what we already know. So factorise and then use the null factor law to get our solutions. Okay. So example 2, we're looking at factorising that. So looking for common factor to start with, and because we can see that there is an x in every one of those terms, we can take out the x, leaving us with 2x squared minus x minus 1 equaling 0. And so I guess straight away we can see that means that x is equal to 0, or 2x squared minus x minus 1 is equal to 0. Okay, so we have one solution already, and we need to see whether can we factorise that quadratic that's remaining. And so we would be looking at finding two numbers that multiply to give -2 and add to give -1, which would be -2 and +1. And so remember, when we're factorising quadratics that have that are what we call non-monic, so the coefficient of x squared is not equal to 1, then we split that middle term up. So it would become 2x squared minus 2x plus x minus 1, and then we can factorise by grouping. So 2x outside of x minus 1 plus 1 outside of x minus 1. So we have x minus 1 and 2x plus 1 equaling 0. And so we can see then, okay, we have our x equals 0 as one option, but we also have x could be equal to 1, or x is equal to -1/2 when we solve the 2x plus 1 equal to 0. So with a cubic we could have, I guess, potential, so we could have either 1, 2 or 3 solutions. So with this next one here, again we've got this common factor of x that we can take out. So x outside of x squared plus 2x minus 10 equaling 0, which means, so x equaling 0 is one of the solutions. Or we need to look at x squared plus 2x minus 10 equals 0. So looking for two numbers that multiply to give -10 and adding to give +2, well, it's not going to easily work, is it? Because we are factors of 10. We're going to be 10 and 1 or 2 and 5. No combination of negatives and positives are going to give us +2. So there may or may not be a solution. So what we can do is we can check by using the discriminant to see if there will be a solution. Okay, so b squared minus 4ac, which gives us, so that's going to be 2 squared minus 4 times 1 times -10. Okay, so that'll be 2 squared is 4 plus 40, so that's 44. So that given our discriminant is positive, we know there are two solutions. So we could just go ahead then and use the quadratic formula. Okay, x equals negative b plus or minus square root of b squared minus 4ac over 2a. So negative b, that will be negative 2, plus or minus, well, we've already got the discriminant part, so we can put our 44 straight in there. So negative 2 plus or minus square root of 44 over 2. So we could get decimal answers, or if the question's asking for exact values, then that would be one solution, but we could simplify it a little more. Okay, square root of 44 would become 2 times the square root of 11. Okay, because 4 times 11 is 44, and then taking the square root of 4 gives us the 2 at the front of the square root of 11. And then if we were to take common factor of 2 out, that'll cancel with that 2 on the bottom, so we could simplify that to negative 1 plus or minus square root of 11. So we have our three solutions, x equals 0, or we have negative 1 plus the square root of 11, or negative 1 minus the square root of 11. Okay, but again, we could use decimal answers for that last bit. Depends on what the question's asking for. If it wants exact values or not. Okay, so that's those two. Then C. When we have 4 terms, okay, we don't necessarily have to jump straight into thinking, well, I need to find a linear factor and then divide it. It could be that we can factorise this by grouping. Okay, so if we have a look and at these first 2 terms and the last 2 terms, the first 2 terms here we have a common factor of x squared, leaving us with x minus 4, and then the second 2 terms we have a common factor of negative 11, leaving us with x minus 4. Okay, and because they're in the brackets, it's both x minus 4. It's worked nicely. So this will factorise to x minus 4 times x squared minus 11. And so then we can solve using the null factor law. Okay, which means we've got x minus 4 equals 0. So x equals 4. Or x squared minus 11 equals 0, which is a difference of squares, or we can bring our 11 over, so x squared equals 11, which means x would equal plus or minus the square root of 11. So we have 3 solutions again. Okay, x equaling 4 or plus the square root of 11 or minus the square root of 11.